Okay, so welcome back. Now we are in week 7. This week the focus, for that week, the focus is on water quantity and quality. So we'll talk about water quantity issue, which is the water resources. You hear the term water resources. That means how much water we have available, and also whatever the water we have available for our use, what is its quality? What are the concerns we have in terms of water quality? Again, as I said in the very beginning of this particular course, that this is an introduction course. It's an EVS, environmental science type of course. As you know, this course is kind of mandated from Honorable Supreme Court that every graduating person from the country needs to take a course like this. So and water we all need. So irrespective of what branch you are studying as an engineer, if you are studying as an engineer or science or a lawyer or a humanities, whatever field you are studying, water, we all of us need water. We all of us need good quality water. We all of us need good quantity of water. We need at least like 140, 150 LPCD liters per capita per day for our consumption. So that's like a healthy lifestyle. So that's we'll talk about all that. So what is the quantity available? You hear from time to time. Recently, you were hearing that Chennai is having a lot of water crisis, and Madras, so Chennai, which is also earlier it used to be called Madras. There has been reports coming in that in few years Hyderabad will have issues in terms of water, and we'll have issue in Delhi. We will have issue in many of the big cities in the country, but we are seeing water stresses happening even in the rural area. And you see from your Facebook or time or WhatsApp, which many of you look at, that's a good you can that's not always authentic piece of information. So you should always be careful what you see there, but many times they are correct, many times they are not correct. So you need to check from other resources too, especially there are a lot of messages goes around which is totally fake and totally untrue, but it's for a certain reason it gets fake. Certain reason it gets sent. I'll not go into those detail right now, but in terms of water, you may have, the reason I wanted to say that we have seen pictures of ladies looking at a well, water is way below, even the ladies getting into the well to get the water out from there. And that's really, it's on one way, on one side we are kind of reaching moon, we are reaching Mars and all that, but on the other side we don't even have basic necessity of water for a good sizable population in the country. So it's a big deal, it's a huge deal. Without water you cannot have industry, without water you cannot survive. So this particular week our focus is looking at the water quantity as well as the quality, and it impacts each one of us throughout the day, throughout our life. So it's very important, like water part. So let's focus on so the concept that we'll cover: water quantity, water quality. So those things. First we'll talk about quantity, how much water is there, and then what is its quality available in terms of its use. So this picture that you are looking at, you must have seen this picture in your school. This is what is known as the hydrologic cycle, or we also call it water cycle. So as we know, the quantity of water that is available is constant. So what is happening is we are just changing the water in different forms. So we have water in the glaciers, we have water in the surface water, we have surface water in terms of sweet water, we also have surface like a salty water and ocean. And then we have the storm water, which is a storm water runoff. If we cannot capture the storm water below the surface, our groundwater gets depleted. Groundwater, which is we'll talk about all those. So there are waters at different pockets at different places. But if you take the total quantity of water which is there, what was there say thousands of years ago is the same water that we have even today. We are not really losing water. So it's not a water. Many times people call about there is a Professor Asit Biswas, he is based in Singapore right now, and he was instrumental in setting up a School of Water Resources at IIT Kharagpur. So, if you ever visit IIT Kharagpur, you will see as you go into School of Water Resources, it's written over there. So, he works extensively on water issues throughout the world, including in Southeast Asia and in India. So, I have attended his lecture once, and I still remember very clearly when he was mentioning that in India, we don't have the like the water quantity is there. The problem is in the management of water. So, the way we are not able to manage our water properly. Right now, say in just this past rainy season, which just recently got over or is still going on, rain in some parts of the country, we had flooding happening. We had flood in Assam, we had flood in south in Kerala, we had flood in even Rajasthan had flood this year. So, that happens almost every other year or every year we see flood happening in places like Bihar, close to Nepal border, in Assam, northeast, south for flood will happen. Even in the western states we are seeing flood happening. Mumbai got a lot of rain. So, what is the problem? So, the problem is we are not able to capture all these rainwater and convert them to groundwater, or not capture these rainwater and put it as a storage in the surface water, which we can reuse. So, what happens? Most of this water just flows away and goes to the ocean, and once it goes to the ocean, it gets all salty. So, then you have to set up those costly desalination plants to get the water out from there. So, the problem is, as Professor Viswa's quote that I was trying to tell you, we have a huge water management problem. If we can manage the water properly. Other example that you see in whenever you go through a rural area, or when you're traveling in the train and you just see the rural areas, if you got a chance, you may be able to see that a tube well just juggling water out, and it is going into the agricultural field, and then many of the water is getting spread around, and that's just getting wasted. Just because the electricity is free or highly subsidized, or diesel is free or highly subsidized for those agricultural operations, we are wasting lots and lots of groundwater. So, we are taking out the groundwater at a much faster rate than what it can that groundwater recharge can be there, and the groundwater recharge methods also we are taking it away. Few years back there was a huge flood in Chennai. And the problem was in Chennai, say 30-40 years ago, we had lakes around more than 200. If I remember correctly, it was 240 or something. You can look it up, you can Google, and you will find a Hindu newspaper had an article on that, and you may find from other Indian Express and those newspapers too. But Hindu had a very exhaustive articles where they were talking about that around 240, if I remember correctly, around something between 200 to 250 lakes were there in Chennai, say 50 years ago. Today that is down to less than 40 lakes. All those lakes got filled up, and we have made those high rise buildings, and people are staying in those buildings. So, those lakes are in they were, so usually those lakes are in, if you look at the contours, they are at the lower elevation. The water from the different areas come there, and then it just goes into that lake. Now, you have taken that lake away, you put those houses, but the water has come, water has to go somewhere, so it will come to your houses. Isn't it? So, that's the problem. So, we are not managing the water properly. We are not doing the groundwater recharge, that this huge right now one good thing that we see that there is some focus back, at least a ministry has been set up which is called Jal Shakti Mantralaya now, Jal Shakti, and they are talking about rainwater harvesting and all that. So, rainwater harvesting used to happen long back. If you go to the villages in Rajasthan, in many villages they have this rainwater harvesting where they used to take the water all the way and put it below, and that used to supply water for almost every year for that particular house. But in the name of modernity, becoming more and more modern, we kind of got rid of all those practices that we used to have earlier. But when I say earlier, it's just like 40, 50, 60 years ago. and then now we are going back, because that's we have to start working on better water management. So as you can see over here, this is how the different forms of water. You have water in the form of condensate, like condensate. You have water, you have surface water. These are your surface runoff. You have a snow melt, precipitation, which is the rainfall, then the condensation. So what happens, the surface water gets evaporated, and then from the leaves and other stuff there is a transpiration, it goes up, forms the cloud, condensation forms clouds comes together, again it rains, and then the cycle continues. So that's your hydrologic cycle, or the water cycle, as it may be called in your different textbooks. So its hydrologic cycles, units of water transfer are around 10 to the power of 12 meter cube per year. So that much 10 to the power of 12 meter cube per year of water just cycles through that in this hydrologic cycle. And here some numbers have been given in terms of how much runoff and precipitation and oceans, evaporation, evapotranspirations and all that. So that's just to give you some context. So sources of water, in terms of we have the groundwater, which is as it says groundwater, so it's kind of below the surface, and so groundwater is located underground in large aquifers. So it could be shallow aquifers, it could be deep aquifers. What is shallow? Shallow aquifers means its depth is not too high, maybe like you don't have to dig too deep to go there, or you can have a deep aquifer which is and then it's pumped out of the ground after drilling a deep well. So that's how you get those. Surface water is found in lakes, rivers, streams, and is drawn into the public water supply by an intake. So you can have both surface water as well as the groundwater. Surface water, in terms of quality, we'll talk about, has their own issue. Groundwater has their own problems. So in terms of groundwater, as you can see over here, you can have here is your so this is your kind of recharge area. The water is coming down. So this is our groundwater at the bottom here, and then another layer of groundwater here. This is called water table, where the groundwater kind of starts, and this is a symbol we use for the water table. So this is here, it's an unconfined aquifer. So this aquifer is like we have access to from this. So we can put some like water table well, we can put some other types of well here and get the water out from there. And this is a confined aquifer because it's in between the two beds. So this is one confining bed, this is another confining bed. So water is kind of in between. So whatever is the water has gone in here, kind of stays here unless we pump it out. So we can use these artesian wells or flowing artesian wells and get the water out and use it. So it's all, so this is how the groundwater system works. So as you can see, we have the water. Say if you have the water in the ground and you start extracting it out as using these wells or these wells, but the recharge doesn't happen properly. If we don't have the recharge happening properly, then what will happen? If this recharge doesn't happen properly, so we will start losing this water, like we will have a less and less water available. So for having a proper balance, we need to have the recharge rate also happening at along kind of comparable to what is happening for in terms of extraction. The problem is with the population increase and the way we are setting up our system, we make lot of impervious layer in our urban area. Especially people will have their house, outside the house they will put some like a concrete path in the front and the back, and then also some walkway, there is a road, then you may have a pedestrian path which is another concrete. So when you put all these impervious layer, so water is not able to get in. So that's why we need to put some recharge system. We need to have this rainwater harvesting where you take the water and recharge, put the water back into the ground. So if you can take the water back into the ground to recharge the groundwater, because then we will, and we have to design it, of course, because based on the rain event, it should be that we should get more and more water inside. You have to look at the type of soil and all that. So there's a detailed design involved in that exercise, but it can be done. It's not that since the water is there, what we need to do is really have a good management of that water. whenever it rains, we need to manage the water properly. Some rivers are flowing, Yamuna was flowing above danger mark during this rainy season. So, we have to get those, and then what will happen, all these waters will end up in the sea and in an unusable form. And if you can tap it and make it in a usable form, then we can have less water problem in say in the next summer. So, that is what, so water management is a huge issue, like managing this water properly. So, as you can, this is another example of how the different water related stuff, including a water treatment plant, which we will talk about later on. In fact, you will take you to a water treatment plant, and then you will see that as well as a video. So, in terms of reservoir water, when it rains, you have the reservoir. There are water is treated. Once the water is doing the treatment, there is a different process which is used for treatment. So, there is a different process that goes in terms of the treatment, coagulation, flocculation, sedimentation, then you have a filtration. We will talk about all these in more detail later. So, you will have this then we have a biological activated carbon again for. So, basically these are the process for water treatment. So, once the water is taken from the reservoir, treated, it comes to the clean water tank, it goes to server reservoir and served to population and industries. So, this is how a typical water system works. So, in terms of treatment, again as I said, we will go in a little bit more detail in terms of. So, essentially what we do, if it is a groundwater, we do not have that much of a problem in terms of fecal coliform and all that. The problem in groundwater is mostly hardness and other stuff. So, we will talk about in the water quality in this particular week, what is hardness, what is alkalinity. Some of this you may already know, but then what we try to let it settle. So, we try to remove the suspended solids, then you do some filter, if there is you do disinfection, and also we go for some activated carbon to remove some of the like if in case there is some contaminants are still left there. So, there are and again do not worry, like in the water treatment we will come back and talk about a little bit more detail later on. So, what are the different intake of a water system? We have an intake and reservoir, there is a water treatment plant which we will talk about in more detail. We have elevated tanks and standpipes, there is valves, hydrants, distribution system and service. So, for any particular city, you all these things are there to make your life comfortable in terms of water, because you get all these stuff like which helps in getting the water in the tap when you open the tap. So, although many times you open the tap, get the water, you do not really realize how much effort goes into getting you that water. There is a lot of effort, a lot of people work on that, and water is taken from a reservoir, goes to a water treatment plant, again it goes to elevated tanks just to create the pressure, then some valves, hydrants, distribution system and service. So, as I said, it's an laborious exercise to provide clean access drinking water. So, do not waste the water, use it judiciously. So, in terms of sources, surface water, as you can see in the picture here, surface water, your lakes, rivers, those are major sources, lakes, rivers, streams, they got drawn into public water supply. Surface water, we always worry about some like a more on in terms of pathogens and other like people will go and use that surface water. In Indian context, there is several traditions as well, that people take bath in the surface water during certain days of the year. So, that's, and when people are taking bath, you have soaps, you have people's like if there are things coming off their body and all that. So, that's those are all needs to be treated. So, you have those those things has to be taken care of before you supply it as a drinking water. Now, there is a concept of watershed as well. Watershed actually is an area where all the water that is it's an area of land where all the water that is under it or drains off it collects into the same place, that is the river. So, it's a watershed for a river. So, all the water, it kind of comes to that. Most of the watersheds are like for example, in most, if you look at the watersheds of different rivers, then you will find that they have a after water gets collected, it goes to a river, and then from river it kind of goes into the ocean. So, there is a one example of here is a watershed. Say if this is an area where things are different interaction that is happening. So, you have precipitation, which is actually another name for rainfall. So, it's you will see precipitation. If you go to weather.com, they do not use rainfall, they use the term precipitation, the chances of precipitation. So, precipitation is essentially named for the rainfall. So, this is the watershed. If you look at the boundaries, if this is the boundary of the watershed, so we have the rain happening here, we have these houses, some runoff and other stuff coming from there, and so if there is a surface water, there is a kind of river, it could be there is a dam constructed for water storage, could be for hydroelectric power as well. And then it kind of comes to a after dam, the river is here. So, the river is also helping the recharge of the groundwater, whatever is the water that is percolating through, that also like infiltration that is happening, that will become part of the kind of can go to the river as well, and then it can go to the bottom. So, you see the groundwater over here, a layer of groundwater which is confined between the two layers, and the stormwater runoff also kind of comes to those river as well. So, this is what just an example of how a watershed looks like, where basically all the water is kind of channeling into one place. So, that's is called like a watershed for that. So, another kind of concept, similar concept, where you have these watershed boundaries given for one particular area. So, here you have some wetlands, you have some tributaries. Tributaries are basically small streams which comes off a river or kind of feeds to a river, and then you have a floodplain of the river, which is a floodplain means the area which gets flooded during the monsoon, during the rainy event, that is your floodplain. So, and everything kind of flows into the river, and then from the river it goes river goes down, and then from river also we have that recharge happening, and the water table we see closer like water, there will be a higher if you start digging into the soil, you find pretty much high water table, especially close to a river. Then you will have the groundwater as well. So, there are, this is again just showing a picture of how the watershed is looks like. So, in terms of water that will get into a surface water, we have a storm water which will come. So, storm water, how much storm water will come, we can estimate that. So, there is a method of estimating the storm water, and it is done using a method which is shown over here. The storm water can be estimated, which is known by rational method as below. The storm water quantity, the flow, which is quantity of storm water, that's Q, which is Q is the term used for the flow, which you will see in many examples in water as well as in wastewater. So, this is our Q, which is the flow. It is expressed in meter cube per second. Q is to find the Q, we take coefficient of runoff, which we will explain in the next slide in a minute. So, what is coefficient of runoff? It depends on the surface, we'll talk about that. Then also intensity of rainfall, like whenever there is a rain, you will have these things happening. So, how much mm per hour for the duration equal to time of concentration. So, which look at the intensity of rainfall, and then drainage area, in what area it is being we are looking at in terms of the drainage. So, that is the kind of formula that is used. So, in terms of the coefficient of runoff, as I said, it depends on the type of cover that you have. When we say type of cover, means type of the surface that you have. If you are in a business area, your coefficient of runoff is pretty high. Why? Because mostly it is impervious layer. See, just think about logically, more runoff will be in areas where you have more concrete roads, more like impervious pavements and whatever, so parking lots and those kind of stuff. So, those are business areas will have those. So, higher the impervious layer, more the coefficient of runoff, because the water cannot percolate down. So, water has to move horizontally somewhere. So, business areas which is has that is an example of coefficient of runoff for business areas 0.7 to 0.9, which is on the higher side. Apartment areas again slightly less than business areas, because in apartment areas you see some like a playground or a walking trail or walking some stuff where water can recharge. Single family areas again slightly better, because you have a front yard, backyard, you have some like a kitchen garden or whatever. So, you have those. Parks, playgrounds, lawns much better because water will percolate down. So, you will have runoff will be much less. Paved street, very high runoff, again very similar to what the business areas are. Watertight roofs has very high runoff as well. So, watertight roofs, which is pretty much most of the roofs these days in many buildings, that is is a good candidate to go for rainwater harvesting, because you can most of the water is trapped. So, you can calculate, you can capture that water and use it for your rainwater harvesting, which will be a you can do it to improve the groundwater situation in your particular area. So, let us look at one example of how we do the estimation. Say if this is a catchment area is 300 hectares, it says calculate the runoff coefficient and quantity of stormwater runoff. If the intensity of rainfall is this, the surface cover in the catchment area can be classified as this. So, if this is the type of cover, coefficient of runoff, and the different percentages are also given. So, we can take a weighted average. So, this area, the entire catchment area, some are roofs, some are pavements, lawns and gardens, roads, open ground and single family housing, and this is the percentage of the area. So, we can, what the first thing we have to do is, if you remember from that formula, Q is equal to CIA by 360. So, we need to know C, I is given to us, A is also given to us. So, we need to first find C here. So, we have been given C for the different types of surface. So, there are the different types of surface, that is type of cover, and for each one of them the C is provided to us, and the percentage of each one of these for in this drainage area, in this catchment area is also provided to us. So, taking that into account, we can calculate this like a overall coefficient, runoff coefficient, which can be like A1, C1, A2, C2 like that, divided by the area. So, we get the overall runoff coefficient as 0.44, and then taking that number into account, you can get your quantity of storm water, which is CIA, which C is your coefficient of runoff. I is the intensity, which if you remember from the previous slide, let us go back. I was the intensity of the rainfall, which is in millimeter per hour, and A is the drainage area. So, we get this I, which is the C is our coefficient. We calculate it based on coefficient given for individual cover and the percentage given in terms of area for that. I was the intensity which was provided to us. If you go back here, I is 30 mm per hour. So, we get that value from there, and then area is 300 hectares. So, we put that value, we put that value over there, divided by 360 as per the area. If you go back and look at the formula, you have to make sure that area is used in, so it says drainage area in hectares. So, that is why we did not make any change in that if say for example, if the drainage area was given to you in terms of meter square or in terms of acre, you have to change it to hectare. So, because these are these equations are mostly what is known as empirical equations. So, you need to be you need to use the correct unit in which is prescribed with that equation. So, in this stormwater quantity equation, coefficient of runoff, which is actually a it's basically a number, no dimension. Quantity of storm water has to be in meter cube per second, intensity in millimeter per hour, drainage area in hectares. So, in this problem the drainage area was given in hectares 300. So, we plugged all these numbers in terms of here. So, that is our coefficient. This is the coefficient number. Oops, sorry. This is the coefficient number, we got put it in there, that is the intensity, that is our drainage area divided by 360, which is the part of the equation, and we got the value of Q in terms of meter cube per second. So, once you have it meter cube per second, you can change it to different format, different unit as you may require. So, that is how a stormwater quantity can be estimated. So, let us stop here for this particular video. So, again this week we are looking at water quantity and water quality. So, we will continue our discussion on water quantity again in the next video. Any question, put it on the discussion forum, and again I will see you in the next video. Thank you.